This is the first in a series of videos about fundamental skills from Math 084. So this time we're going to talk about finding the equation of a line. When you go to find the equation of a line, there are two possible situations. The first is you know what the y-intercept is, and the second situation is when you don't know what the y-intercept is. So let's look at this example first. This one we do know what the y-intercept is, because if you look at the graph right here, one of the points that we know on this line is the y-intercept itself. Incidentally, these whenever you have sort of bigger points on a line, this is meant to indicate that that point really is on the grid intersection that it looks like it's on. So this point right here, right there, that's 0, 3. I'm sorry, 0, 2. And since that's on the y-axis, that is the y-intercept for this line. So since we know the y-intercept for this line, we can use the slope-intercept equation for a line. And that is y equals mx plus b. And b is the y-intercept of the line, or the y-coordinate of the y-intercept. And we already said we know that. In this case, it's 2. So the only thing left to do to figure out what the equation of this line is to find the slope. And the slope is m, this number right here. There are a couple different ways to find the slope depending on what you know about the line. In this situation, I'll show you one way of finding the slope, and then on the next example we'll use the other way. So in general, the formula for slope is change in y over change in x, or you might have seen this expressed as rise over run. So when we're looking at the graph of a line like this, one quick way to find the slope is to actually just count what is the rise and what is the run as you move from one point to another. So starting at this first blue point, let's count the moves over. So we go over 1, 2, 3, 4, 5. So that's 5 over. And up 1, 2. So 2 up. So our rise is 2 and our run is 5. And so our slope is 2 over 5. You can see when you have the graph of a line, finding the slope just by counting the move like this is pretty fast, which is one advantage of this way of doing it. Incidentally, if you move to the right, that's going to be a positive run. If you move to the left, that's a negative run. If you move upwards, that's a positive rise. If you move downwards, that's a negative rise. So if we moved from the right-hand point to the left-hand point, we would be going 1, 2, 3, 4, 5, but that's to the left, so that would be negative 5, and down 1, starting here, down 1, 2, so that would be negative 2, and so moving from the right to the left, for our slope we get negative 2 over negative 5, but that's still 2 over 5, so either way you get the same thing for the slope. Alright, so now we know our slope. We can put that into our slope-intercept equation. Y equals 2 over 5 x plus our y-intercept, which we said was 2. And there we go. There's the equation of that line. Y equals 2/5 x plus 2. You can see when you know the y-intercept, finding the equation of a line is pretty straightforward. So now let's look at an example where we don't know the y-intercept. So down here on this line, we still have a couple points where we know what the points are because, again, the big dots emphasize that these 2 points are on the grid intersections it looks like they're on. But it's hard to tell what exactly the y-intercept is. Maybe it's -6, maybe it's -5 point something. It's hard to tell, so we can't be sure. If you can't tell exactly what the y-intercept is, then you can use the point slope equation for a line. And the point slope equation for a line looks like this. Y minus y1 equals m times x minus x1. So in this equation, m is still the slope, and x1 and y1 together are any point on the line. Since we have 2 points on the line, we'll be able to choose which one we want to put in for y1 and y2. I'm sorry, x1 and y1. So first let's find the slope. Now on this example, we could find the slope by counting again, but just for variety, this time let's use the formula for slope. So this point on the left, reading the coordinates off of the graph, it looks like its x-coordinate is -3. And its y-coordinate looks like it's -4. And this other point looks like its x-coordinate is 1, and its y-coordinate is -7. All right. So now let's find our slope. So the formula for slope is rise over run, but rise is y2 minus y1 over x2 minus x1. All right, so for y2, we can choose one of these two y coordinates, either -4 or -7. You actually can use either one as long as you're consistent about which point is the second point and which point is the first point. So I'm going to use this -4 as the y coordinate that comes first. So I'll put my -4 in there, and that means the other y coordinate, -7, is the second one, like this. Now in the denominator, since I chose the y coordinate for the left-hand point first, I have to choose the x coordinate for the left-hand point first. So I have to put the -3 right here. I can't use the other x coordinate, 1, and put it here. So I have to keep them in order. So -3 minus the second x coordinate, which is 1. And now I have to do all this arithmetic. So let's see, -4 plus -7, I'm sorry, minus -7, that's really plus +7. So -4 plus 7, that's 3. And -3 minus 1 is -4. So the slope is -3 over 4. All right. Now we have our slope. That's the hard part. For y1 and x1, we can use either one of these 2 points that we already wrote down. Really, you can use either one. It doesn't matter. You'll get slightly different equations, but both equations will actually be the same line. So just to switch things up, let's use the other point this time. So the point that we're going to use for x1, y1 will be 1, -7. So putting this into our equation, we get y minus -7 equals x times, the slope, which is -3 over 4, times x minus the x coordinate for that point, which is 1. So this is the point-slope equation for that line. Now really, we should simplify this. So one thing we should do is replace this minus -7 with a +7. So y plus 7 equals -3 over 4 times x minus 1. And often, once you have the point-slope equation for a line, you'll want to get the slope-intercept equation for that line. And remember, the slope-intercept equation for a line just looks like y equals, and then a bunch of stuff. So to get this into slope-intercept form, we just need to solve this equation for y. So let's start by distributing this -3 over 4. So y plus 7 equals -3 over 4 x plus 3 over 4. Right, negative times negative is positive. And then we can subtract 7 from both sides. And while I'm at it, I might as well write 7 using a denominator 4. So 7 is 28 over 4. So I get y equals 3 over 4 minus, so 3 over 4 minus 28 over 4, that's negative 25 over 4. Oh, and I see I've left off my x in here. So there's our slope-intercept equation for that line. Y equals negative 3 over 4x minus 25 over 4. Incidentally, this y-intercept right here is negative, let's see, it's going to be negative 6 1/4. And if you go back up to the graph of this line and look at the y-intercept, it looks like it's about negative 6 1/4. If you look right here, about negative 6 1/4. I didn't draw the line perfectly, which is why the y-intercept isn't in exactly the right place. But this shows you the advantage of having the equation for the line. You can figure out exactly where the line is without having to believe a graph that might not be perfect. Next up in the series on fundamental skills from Math 084, we'll look at graphing lines.